Good morning. I'm back, and we are going to be doing system of equations today. So there are always system of equation problems on the SAT. So we're going to dig right in. We're going to go to test 1, section 3, and we're going to do two different questions, 9 and 18. We're going to do more than that, but in section 3, we've got two. So we've got two equations. Okay, so let me write them down first. And before we even get into solving the problem, there's an inherent issue here that I want to talk to you about and see if you can figure it out. We don't have our x's and y's aligned. So I want to align that. I'm going to do it up here. So I like the way the top one is because we have the x first, and that is just normal. We're used to seeing that. But now I want to put this in its proper order. The thing that you have to remember is to keep your sign with you. So that is going to be a negative x and a positive 2y, and that's going to equal negative 19. Now, the way I like to do system of equations is through what's called the elimination method, which you may remember from school. But there are actually two ways to do this problem. You can use the elimination method, and that's what I am going to show you. You could also just plug in the answer choices. When you have answer choices that look like a set or a coordinate, in this case, this is -5, -2, right? You could decide to just go through all of the answers and plug in for x and y and see which one works. It's a valid method. It will work. But I think in this case, it's going to take possibly too much time. And anyway, I want to make sure that you absolutely know the elimination method. So the elimination method looks like this. We have x's, we have y's, we want to solve for one of them. And let's just say in this case, we want to solve for y. What we want to do is multiply one of these equations so that by something. In this case, let's do the second one. If we multiply it by a 3, we're going to get a negative 3x. And when we add these two straight down, those are going to cancel out. So let me show you what it looks like. I'm going to rewrite it back down here. So the first one stays exactly as it is. We don't have to touch it. The second one, we're going to distribute that 3 out to all 3 parts of this equation. So now we're going to get a 3 times a negative x is negative 3x. 3 times a 2y is a 6y. And 3 times negative 19, we're just going to do that off to the side. You cannot do this, remember, on a calculator. So we're going to get negative 57. And when we add straight down, whoop, those cancel out. We get a 10y equals negative 80. We divide out the 10, and we're going to get y equals negative 8. Now, when we look at the answer choices, you'll see we only have one answer that has a negative 8 in the y spot, right? And that is going to be B. That's all you need to do. You don't actually need to solve for the y. I mean, for the x. Okay, great. Now, let's go to the same section, number 18. All right, it's a similar type of problem. I think we have room enough to do that here. All right, now, this one says it's a little bit simpler. We've got x plus y equals negative 9. And x, that's nice. They put them in the right order. The x's and y's are aligned. And we've got a negative 25. Now, in this time, the question is asking us to solve for x. So we definitely want to leave x in. We're going to try to get rid of the y. And if we multiply the top equation by negative 2, that will solve our problem. So instead of rewriting all of them, we can just bring this top one down. And we're going to distribute out that negative 2 to all of the elements. So we're going to get a negative 2x and a negative 2y. And we have a negative 2 times a negative 9, which is going to be positive 18. So our y's cancel out. We're going to get a negative x equals negative 7. And we can just switch over those both signs. And we're going to get 7 as our answer. And there it is. Okay, now let's flip over to section 4. I'm going to clear this off. Section 4, we're going to go right to number 19. And pardon the rustling of pages. Okay, so test 1, section 4, number 19, and we have a word problem. It says a food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of well, you know what? Actually, I'm going to follow my own advice. We've got salads are $6.50. Drinks are $2. All right. Now, the revenue from selling a total of 209 salads and drinks in a day. So again, 209 total. And then the revenue is $836.50. So $836.50. That's total revenue. Okay, so this is number, and this is dollars. And I want to point something out here. This is really important. The way you know a word problem is a system of equations problem is that you have 4 different items. You've got here, you've got salads and drinks, that's 2. And they're telling you 2 different things about those salads and drinks. One is the number of them, and 2 is the money that they bring in. That's how you know you're going to have a system of equations question. So you come up with 2 different equations. All right, so one is going to revolve around the number, the other one's going to revolve around the money. So our first one is salads. We're going to do the number first. We have the salads and the drinks. Well, they told you they sold 209 salads and drinks. The next one is the money, and that's when you attach the money to the salads and drinks. So we've got let me get that decimal point, 650S plus 2D equals 836.50. Okay, now we're going to do something with it, right? Now we have to read the question part. How many salads were sold? Okay, great. So we want salads. That means we want to get rid of the drinks. So we have a 2D and a D. We can multiply this top by negative 2D. Remember, you want them to cancel out, so you have to consider that sign. And if we bring that equation down, remember, we're distributing properly to everything. We get a negative 2S minus a 2D, and that's going to equal a negative 418. Okay, I'm going to go back to black, and we've got a 4.5S. Those cancel out, and we've got a 418.50 over here. Then we just do regular math, divide out that 4.5, and luckily we are in the calculator section. So you can do this by calculator and you will get 93, and 93 is your answer. That is B. All right, so that's it for test number 1. And I think I'm going to clear this out. And let's go to test 2. We're going to do section 3, number 2 and 20. All right, so let's keep going with this. Number 2, well, you know what? I'm not going to do number 2 because it's very, very similar to the other one that we just did. So let's go to number 20. And that one is a little bit different. We see lots of variables in this. And you might think, uh-oh, I don't know how to do this. But I'm going to show you how to do it. And I think it's not too bad. All right, so we've got this set of equations. And then it says, in the system of equations above, A and B are constants. That's fine. If the system has infinitely many solutions, what is the value of AB? So there's two things. First of all, they want us to find AB, and then this infinitely many solutions, right? If equations or lines or anything have infinite solutions, what does that mean? Well, I mean, it means that any number of numbers can go into that equation and make it true. One simple way of thinking about it is if it says x equals x, solve for x. That would be an example of an equation that has infinite solutions. So that means the sides are equal. This means that these two equations are equal. Now, the problem is there's not a lot of ways to tell that they're equal because we've got A in for X. I mean, A in where, here's A and here's 2 and here's B and here's 8. And we don't know what these numbers are. They have to be different because the result is different. But we can, in fact, look at the results. We have a 12 here and a 60 here. Now, if you multiply 12 by what? 5, or really, you'll get 60. So what we need to do is make these equations equal by multiplying this top one by 5 so that the result is 60. So let me show you. We're going to bring it down here like we did before. And again, we're going to distribute everything, or that 5 out to everything. So it's going to be 5ax plus 5by equals 60. Okay, now remember, when you have two equations that are equal to the same thing, in this case, they're both equal now to 60, that means they're equal to each other. So if they're equal to each other, that means the x's are equal, right? So you could say that 2x equals 5ax, right? And we're trying to solve for AB, right? So we could solve for A by dividing out the x and the 5. And the x's would cancel. So A equals 2/5. And then we can do exactly the same thing with the b's the y's, because the y's are now equal. So we have 8y equals 5by, and we're trying to solve for b, so we can divide out the 5y. The y's cancel out, and b equals 8/5. Now, we're trying to solve for a over b. A over b is going to equal 2/5 over 8/5. Now remember how we divide out fractions. 2/5, I'm just going to take it step by step. You can't do that, right? You have to turn it into multiplication. And then you flip the second fraction. And then you can multiply straight across, or you can cancel out the 5s. Either way, 2/8. The answer is 1/4. Okay, that's number 20. All right. The next one we're going to go over, I'm going to clear this out, is we're going to do test 2, section 4, number 9. So let's get there. And this is an interesting one. It's another word problem. It says a worker uses a forklift to move boxes that weigh either 40 pounds or 65 pounds. So I'll write that down, 45 pounds or 65 pounds. Let X be the number of 40-pound boxes. Oh, I said 45. Okay, 40. So this is going to be X, and Y be the number of 65-pound boxes. Okay, so I'm just making that notation. The forklift can carry up to either 45 boxes or a weight of 2,400 pounds. So up to 45 boxes or 2,400 pounds. Which of the following systems of inequalities represents this relationship? So it's not a system of equations because there's no equal sign, right? There's inequality signs. Okay, so it's system of inequalities. All right, so now here we have our two elements, which are pounds and number of boxes, right? So let's work with number first. I would like to work with the number first. So they told us that the number of 40-pound boxes is X, and the number of 65-pound boxes is Y. And we know that the two of them together, it says can carry up to 45 boxes, which means it can't be over 45 boxes. So it can be less than or equal to 45. Now, if we go to the answers, I'm going to throw the answers in here, or the letters anyway. This is our first thing, right? So we know this to be true. Let's look and see if there are any answers that don't have that. And we can see B doesn't, right? That says, oh no, B does. B is good, A is good. C and D are no good. We can get rid of C and D. Great, we've got a 50-50 shot now. We just have to deal with the pounds. So we've got the number done. We've got the number done. Now we've got to attach the pounds, right? So we have 40 pounds is the X. So it's going to be 40X. And then 65-pound box are the Y's. So it's going to be 65Y. Now we can actually stop right here and look at the answer choices. A is the only one that has this configuration. It has to be A. B is not going to work. Isn't that nice? You don't even have to deal with the rest of the problem. I mean, it wasn't that big a deal. It was just the inequality sign in 2400, but I'm showing you a particular shortcut so that you don't have to necessarily work through the entirety of every problem. Okay, so that's that. Now, that's it for test 2. So now I just want to show you some concept problems. Let's see. All right. Another type of problem that they could give you is slightly more complex. So you might have something like this, and then 3x minus 2y. And that is -6. So here, you cannot multiply one of the equations by any number to cancel out either the x or the y. You can't do it. This is why it's a little more complicated. You actually have to multiply both equations by something, and you get to figure that out. So let's say, and let's even make it a little bit harder. Let's say they're asking you for x minus y. So you have to figure out what both of them are. Okay, so it doesn't matter which one we try to get rid of first, because we are going to be solving for both. So let's just say we're going to get rid of the x. If we multiply the top one by 3 and the bottom one by -2, and then we rewrite them. Okay, I'm going to rewrite them both after we distribute. So the top equation is going to go right here. And that's going to be distributed out 6x minus 9y equals 14 times 3 is 1242. So that's going to be -42. The bottom one is going to be -6x plus 4y equals 12. Okay, and you can see this one is going to maybe take a little bit longer because you have to really think about what they're both going to be multiplied by so that they cancel out in the end. The 6's cancel out. We have a negative here, so this is going to be -5y equals -30. Divide out that 5, the -5, and we get y is 6. Now we can plug 6 back into, let's just put it up here. All right, and now I'm going to do this in a different color. We've got 2x minus 3 times 6 equals negative 14. Now we can just solve for the x, yeah? Oops, that's a negative 14. If we add 18, we're going to get 4. 2x equals 4, x equals 2. And now we have x minus y. We come back up. We've got a 2 for the x, a 6 for the y, and we're going to get negative 4. And that's our answer. Okay? All right, so this is the more complex type of question for system of equations. All right, let's see if there's anything else. You know, there is one more that is slightly more complicated. So let's say we're talking about detergent and a fabric softener. Okay, so we have detergent and fabric softener. And there's a supplier of these things, and they will supply no more than, you should get familiar with this languaging, 300 pounds of both of them together. All right, now let's just make up some poundage. Let's say the detergent comes in 10-pound boxes and the fabric softener comes in 7-pound boxes. All right, and then it says the person they're delivering to wants twice as many containers, I'll just say boxes, that's shorter, of let's say detergent than the fabric softener. Okay, now, and then the answers are going to be a system of equations, and you need to figure out what they are. All right, so again, we have the pounds, and we have the number of things. All right, now, they don't tell us how many pounds, how many like boxes of these are, but they do tell us there's twice as many. Okay, this is the hard part. Okay, it sounds like it's going to be twice as many is 2D, and that's going to be greater than or equal to S. Okay, so, and let's just say at least twice as many. And that would be the reason for the inequality. That's what I forgot. Now, this seems to make sense, but what you need to do is test this. And when you do test it, so let's say there's 3 boxes of detergent. Well, 2 times 3 is 6. So what happens is you have twice as much fabric softener. And let me just make that an F. Okay, you have twice as much fabric softener as you do detergent. So that is not right. Even though logically it seems to make sense. If you switch it, actually, let me do it this way. If you switch it and then you plug in your numbers, you've got 3 here and 6 there. Now you have twice as many detergents as fabric softeners. This is the way you want to see it. Okay, so I want you to really take note. Twice as many boxes of detergent of something than something, you kind of flip where the 2 is. And if you're not sure, just plug in numbers and get yourself sure. Okay, you can always test the work that you do. And I highly recommend that you do that. Okay, that's all I've got for the system of equations. Have a wonderful day, and I'll see you next time. Bye-bye.